Okay, so when we're doing number 13, it's a proportion. And so we're going to have 5/3 equals 2 over x plus 4. And you should have done these in Algebra 1, so hopefully we're just kind of dusting off the cobwebs. But we're going to cross multiply, or I think some teachers call it like the butterfly. Does that sound like familiar? It depends on the teacher you have, I think. Because that kind of looks like a butterfly, I guess. I don't know. But we're going to cross multiply. So we're going to say 5 times the x plus 4. So 5 times the x plus 4 equals 3 times the 2, which 3 times 2 in this case is just 6, right? And so now it's set up kind of how we're used to it. And so in this case, you do need to distribute. So we get 5x plus 20 equals 6. Off the screen. We're going to subtract 20 from both sides. So we're going to get a negative what? Good. And then divide both sides by 5. And so x is negative 14 over 5. 5 and 14 don't have anything in common, so I can't reduce it. If we wanted a decimal, we could use our calculator and get a decimal too. Okay. But negative 14 over 5. So hopefully, I just wanted to recall proportions for you. Okay, the last section that I'm going to go over with you is called literal equations. And literal equations you did do in Algebra 1, but it's one of those topics that students struggle with. And so in Algebra 2, we go over it again. And so literal equations are taking like formulas, mathematical formulas, whether they're in geometry or college algebra or even physics, like some of these are in physics, right? So we're taking actual formulas and we're rearranging it so that we're solving for a different variable. There's no number, like we're not solving, like in this case, we just got negative 14 over 5. We got a number, right? With literal equations, you're just rearranging. That's all you're doing. Okay, so you're not going to get an answer. Okay, so I want to make that clear. So let's try one. Does anyone know 15 what formula that is? Think back to geometry. That one's in geometry. It's circumference. Circumference of a circle, yeah. Okay, so 15, that's the formula for circumference. So what it's telling me over here on the right is saying solve for pi, meaning it wants pi isolated. It wants pi by itself. That's what that means. So right now we have c by itself. So we have c equals 2 times pi times r. Remember, r is the radius, and c stands for circumference in this case, okay? But it's telling me, hey, isolate isolate pi, okay? Well, how is 2 and pi and r connected? What operation is connecting them? Multiplication, good. So these are all being multiplied, okay? So to get rid of 2 and r, what's the opposite or the inverse operation of multiplication? Division. So I can divide by 2 and r. Now, could you do it separately? Yes, but this is faster, right? So I'm going to divide both sides by 2r. What that's going to do is 2 divided by 2 goes away. That's 1. And r divided by r, that's 1. That goes away. So I'm left with c divided by 2r equals pi. And so now I've solved for pi. Did I actually get a number? No. Right? But it's kind of interesting because pi, we know, is a number. I mean, it's a number that keeps going, right? But it is a number. And in this case, we can say, okay, any circumference divided by 2 times its radius is going to give us pi. And that's why this one's kind of interesting. A lot of math teachers don't bring that up. That's why pi is so interesting, right? Because it's a number, and a lot of people understand that, but they don't understand what that means. And really, when you get into pre-cal, it gets a lot of fun, just so you know. Okay, pi is brought up a lot in pre-cal. Okay, so again, any circumference divided by 2 times its radius is going to give you pi. Kind of interesting. Okay? But in this case, all we cared about was rearranging it for algebra 2 purposes. All right, let's do one more. So these are called literal equations again, just so you're familiar. Let's do one more though. This is another geometry. This one's not as familiar. Not all geometry classes do this. Sometimes it's just the pre-AP classes. This formula for 16 is the area of a regular polygon. So if you have a regular polygon, you have something called an apothem. I don't know if any of you had a geometry teacher that taught you that. But anyway, that's what the little a stands for. The P stands for perimeter. The little p. Again, you don't need to know what the formula is. It's just kind of interesting. Okay. So in this case, we've got an area formula, but it wants us to rearrange it where we're solving for the perimeter, which is P. Okay. So we're going to take A equals 1/2 times that little a, which stands for apothem, which you guys might not know that. That's fine. Times P. Okay. Now we want to isolate P. Okay. How are all of these over here connected? Multiplication again. Okay. So in this case, how do I get rid of a fraction? Like if I multiply by what, it'll get rid of this fraction. It's reciprocal, which in this case is 2, because if I flip 1/2 over, it's 2. So to get rid of this denominator, I want to multiply by 2. Okay? And so if I multiply both sides by 2, that's going to get rid of my fraction for me. And I'll be left with 2 times A is equal to little a times P. Again, this big A stands for area and the little a stands for apothem. They're different, okay? Now, is P by itself yet? No. One more step. How do I get rid of the little a? How are they connected? Multiplication. What's the opposite? Division. All right. So now I've solved for P. So P is equal to 2 times the area divided by the apothem, which you may or may not know what that is. And that's going to equal the perimeter. Okay. So now if you were given a geometry problem where you wanted to solve for the perimeter and you had these already, you've already rearranged it. So it's kind of nice. Okay, so literal equations is just rearranging, guys. Okay, it's just rearranging. Okay, I'm going to let you work